That means you're telling me I might have to take that and start teaching.
It could have been just really good.
Oh, I got you. Okay.
Yeah, I
Okay.
would.
I didn't notice that. We'll see.
Yeah,
Okay.
it could have been just that.
Okay. All right. Thank you. Okay, let's go. Put them away. I think we're ready to rock and roll. Okay. So, do this. Hey, Chantel. Is she still there? Hey, what if, do they make better powered ones of these that might give me a better signal?
We don't offer them at all.
Well, no, but do they make
But
it?
I have no idea.
Oh, okay.
Yeah.
And say if I bought, I like to be able to see my kids when I teach, you know what I mean?
Yeah, I have no idea.
Okay, alrighty. Okay, so again, what I do is I create myself a 3x5, and I literally go through every question that's on the test, and I write stuff that's going to help me remember to make sure I cover that topic. And so what we'll do is we'll literally go through my entire 3x5. I will do some housekeeping stuff, and then you will have the rest of the time to work on whatever it is you need to work on. Okay. All right. So you got to make sure you know the difference between a physical and a chemical change. Okay. Anybody know how to tell if something's a chemical change? Yo, Bella. What? Okay. So heat is derived. That's one thing. What else? Anybody know? You get a lot of times what they refer to as something new. Like when you burn a piece of wood, right? You're left with something that's completely different, correct? Whereas if you just take that piece of wood and you run a chainsaw through it, you just take it from one big piece of wood to a whole bunch of little small pieces of wood, right? But it's still wood. That would be an example of a physical change. Things like, melting something. I melt gold down. It's now liquid, but it's still gold. Melting, and the complement to that would be, well, not the opposite. What would be the next thing? You melt it, then you boil it. Melting, boiling, things like that are physical, whereas chemical change, you get something new, and that is often accompanied by heat. Okay? You got to make sure you know the states of matter. The states of matter, solid, liquid, gas. Anybody remember the difference between a solid and a liquid? Besides the textbook definition, they show you a picture. And they're trying to distinguish between a solid and a liquid. Anybody remember what I said? Yes.
Doesn't the solid have like a pattern?
Yeah, solid has that order, whereas a liquid, they're still touching, but there's no longer that order there. There's no pattern there. Okay? Let's make sure you remember that. Probably the biggest topic is going to be sig figs. Okay, sig figs. Now, one thing I will tell you, I found a video online. Some YouTube dude put it out. It's like 7 minutes. Okay, I actually copied the link and put it on your video page. So it'll be right before this video. It'll say something about a sig fig. It's only like 7 minutes. I would go and watch it. He does a really good job. And there's a, how would I put this? There's a question on the test that it answers. Let's put it that way. So I would probably go and watch that and just kind of make sure you're familiar with that. But with that, there's three main types of questions they're going to ask you with sig figs. One is when they just straight up, how many sig figs does this number have? Then you're really just worried about like the zero rules we learned the other day. Okay, but then they're going to do some calculations, which we will walk through a couple of them today. Calculations. And then exact values. Okay, exact values. Does anybody remember what made something an exact value where it did not impact your sig figs? I use one example. It's when it's a what?
Counting.
Yeah, counting number. Counting numbers don't count. Okay? Wow. I wrote something down and I cannot read what I wrote. I don't know. It's right there. And I do not know what that says. It starts with an I, I'm guessing. In something. I'll remember it eventually. Alrighty, so if I gave you, 404.240, how many sig figs does that have? Anybody remember? 5 or 6? 6. Why 6? It's got a decimal in it, right? If it's got a decimal in it, that 0 is going to count. When does the 0 not count if the number has a decimal in it? And if it's in front. So if I had 0.00400, that now has how many? 3, right? These 3 do not count. Those 2 do count, right? Okay, so just keep that in the back of your mind. Alrighty, so scientific notation. Scientific notation, verse. And they refer to it as standard form. Okay, you've got to be able to go between the 2 of them. So if I gave you 1.27 times 10 to the 4th, what would that equal in standard form? 12,700 like that? No? One more 0, 12,700 like that? Can I put a decimal or anything in that number? Why not, Brian?
Because then it doesn't affect the sig.
Exactly. This number had 3 sig figs in it. When I rewrite it, it's got to maintain the same number of sig figs. Okay? Same thing if I go the other way. If I go, if I went 0.002760 and I wanted you to put that into scientific notation, what would that be? Say it again. 2 point times 10 to the 6th. I'm going to go 1, 2, 3, right? But it's going to be -3. Is he right?
No.
Why not, Harris?
0.
What?
It's gotta add a 0.
Yeah, this number had how many sig figs?
4.
It had 4. This number must remain with 4. I got to have that 0 on the end. Okay? Counts because I got a decimal in there. Okay? Something that I would definitely put on my 3x5. Have we talked about that? You guys can have one 3x5 handwritten on one side, no magnifying glasses. Okay? An example, this was one from last year. Not this test, obviously, but that's, what I want to see. And I actually checked them, so, okay? But the metric tables. The metric tables, okay? And they are pages. These are the following pages. They're pages 10, 12, and 13 out of the text. Paying special attention to this symbol. Let me know what that symbol is.
Micro.
Micro. Make sure you know that. Make sure you know those units. Okay? I'm going to be honest. I know the exponents. I know what they mean. Most teenagers do not know this one. Make sure you know how to get. Like if I wanted to go from grams to micrograms, make sure you can do something like that. Okay? So look at those, and I believe that's on 10. 12 and 13 are full of some of the more common conversions. The 2.54 centimeters in an inch, 2.2 pounds in a kilogram, those kind of things. But I will say that they did a really, whoever put this test together did a really good job of matching it up with the homework questions. So like you go back and you look at that homework, like the one medicine one where you're taking, you want to give this kind of dosage. Who knows the question I'm talking about? Yeah, that kind of stuff is the kind of stuff you'll see on the test. Very, very similar. Okay, so make sure, the one, it gives it in kilograms or it gives it in pounds, right? And you've got to get like milligrams per kilograms, okay? It's that kind of stuff. Make sure you know those values, okay? Next thing is density. There are a couple of density. and specific gravity questions. Okay, density and specific gravity. We did density, mass divided by volume. That's just one of them. We went through all three of them. I think this should be easy, right? What was specific gravity? Anybody remember?
Density of a substance divided by the density of water, which is 1.
Yeah, the density of the substance divided by the density of H2O. The density of H2O. What was special about specific gravity? Probably the only thing that won't have any what?
Unit.
Yeah, it is unitless. Unitless, and it's probably one of the few things that has no units. But it's really just a comparison of the density of whatever it is you're talking about divided by the density of water. And really all it does, the number doesn't what? Number doesn't change, it just gets rid of the units, okay? Now, one thing they do is they compare some densities here, okay? Now, if I were to say this, if I were to say this question, given two substances with the same volume, okay, if substance A has a mass that is 2 times, that's supposed to be an S, that is 2 times greater than B, how would its density compare? Anybody follow that? Yeah, it'd be 2 times greater, right? Okay. So just kind of understand how they're worded. They ask, obviously this isn't exactly what's on the test, but it is. There is one similar to this where you've got to kind of think through, okay, so if this one is this, and really it's going to be a situation where it's either going to be 2 times greater, it'd be the opposite of that, and it'd be half as much or 2 times less. So just kind of think through them, just understanding that most of the time you've got something, you've either got this or you've got this, mass equals volume times density, right? Well, in this situation, for my density to be the same, if my mass goes up, what has to happen to my volume? Anybody know what kind of relationship this is? Nobody? It's called direct, meaning if one goes up, the other one must also go up for them to stay the same, right? But in this case, where they're now multiplying, does anybody know what kind of relationship this is? Yeah, it's what? No. Close. Starts with N. It's called an inverse relationship, meaning for my mass to not change, if my volume goes up, my density must go down, right? Because they're times it gets inverse, they're dividing, it's direct. One goes up, the other goes up. Okay? And it's just that they give you a word problem that is very similar to this. That's really it's a thought process thing, you know. Okay. Got to be able to do temperature conversions. Okay, so if I gave you, let's say I did 135 degrees Fahrenheit, and I said to put that into Kelvin, does anybody know what you'd have to do? Add 273?
No, you have to convert it to Celsius.
I got to convert it to Celsius and then add 273. So how do I go to Celsius first? And remember, I'm going to take my degree Fahrenheit. So I subtract 32 degrees and I divide by what? 1.8. Is she right? Yeah? What do you get? .2 repeating degrees Celsius. Now what am I going to do? Add 273, right? And that's going to give me, say what? 330.2 Kelvin. She right?
Yes.
Yo.
Do you have to do the sig figs?
Yeah, I have to do the sig figs. How many sig figs does that have? 3. How many sig figs can my answer have? 3, right? So what would I put there? That has 4, doesn't it? How would I write this? Just go 330 like that?
With the decimal.
Ah, gotta have the decimal. Without that decimal, that only has 2. Put that decimal in there. And what you'll notice, this is something, I don't remember if I talked about this yesterday at all, or the other day, but 273 is a given, which means it probably shouldn't do what? Probably shouldn't impact my sig figs, right? But there is one thing that I kind of wonder about, and that is that I have never seen this with a decimal on it. Because right here I'm adding, correct? When you add, it's only number of decimal places, right? Well, if this one doesn't have any decimal places, in theory, my answer probably shouldn't have any decimal places, right? I will look that up on the test to make sure that is correct. But I'm pretty sure. I went over it again this morning, but it was really early. So I will look at that. But yeah, you got to have that on there, and then you got to have the units for Kelvin. Okay? So that's that. All right. Does anybody in here know what the term diatomic means? Diatomic. What does di mean? No. 2. Atomic means atoms. Does anybody know the diatomics? There's 7 of them. Nobody? H2, O2, N2, F2, Cl2, Br2, and I2. These are what are called the diatomics. Okay? So when we breathe oxygen gas. Okay, what we breathe is we breathe O2. Okay, we actually breathe air. Our body just does what? It filters and uses the oxygen, right? Now, from there, what you need to understand is this, is that, let's say I take H2. Is H2 a compound? Yes? No? Why do you say no? It's the same. To be a compound, it has to be 2 or more different. What is it, though? It's something similar to a compound. Yeah, it's a molecule. Now, what you got to understand is that people often use molecule and compound interchangeably. They're not. They're similar because a molecule is 2 or more atoms bonded together. A compound is 2 or more different atoms. That's the key. Is I can have a molecule that are all the same atoms, but it can't be a compound. Okay, so if I take C6H12O6, that is a compound. But it is also a molecule. Because is it 2 or more atoms bonded together? Yes. But it's also 2 or more different atoms bonded together. So it would be a compound and a molecule. So make sure you pay attention to that. Okay? Then we already did mass versus density relations, right?
Yep.
Okay. Still trying to figure out what that word is. It's right here. I want to say it's I-N or M or...
Verse, or like,
Does it say important?
exactly like things that is
Looks like
exact-
important.
It's like INP or
I don't know. If I figure it out, I'll tell you before we take the test. That's frustrating. Alrighty, so that is everything. Now, a couple things we need to talk about. First thing we need to do is we need to talk about due dates. Okay? Now, in Chapter 2, this is going to change a little bit because then we'll all kind of be kind of be on the same page. But something you need to understand is that everything is due, no matter what, the night before the test. So for you guys, what the computer says and what is actual reality is not the same thing. Because I can't separate classes out. Because I teach this on A day and B day, I have to put in the same due date. You know what I'm saying? But I can't have theirs due ahead of time because then that's going to give them an unfair handicap, if you will. But I'm also not going to put yours back because then it doesn't do you any good to do it after you've taken the test. You know what I'm saying? So your due date will always be 11:59 p.m. the night before the test. No matter what. That's when everything's due. Okay, now when we say that, that's going to be homework from now on because we'll do the Learn Smarts as we go next chapter. Does that make sense? But for homework, it'll be due, for this chapter, they'll be due 11:59. Now, what day? Hey, they're going the same direction.
I figured it out.
Yeah, hey,
Flip the paper and reverse it.
he's, that's not that bad.
No, I just don't know how much he'll actually attend.
Okay, that was going to be my next question.
He's working full time.
Okay.
8 to 5 kind of stuff. So
Oh.
we'll probably just do packets.
Okay, I'll call him.
Okay.
Alrighty, so for us, we're going to take the test on Monday. So that is going to make Monday the 14th, right? So all your stuff is going to be due at 11:59 on 8/13, no matter what. That's it. Okay, and remember what we said about homework and labs. You can't afford to do what? Nobody remembers me writing those percentages up there? You need to get 100% on your homeworks and your labs. That means the lab is also going to be due. Okay, lab is due when you walk in. When you walk in on Monday. That's the first thing I'll do. Now, in the lab, did I go over the lab with you guys? Okay, we're going to do the lab at home because they cut out our lab day. Now, every lab consists of 3 parts. The first part's called the pre-lab. And down the road, when you walk in, that's the first thing I check and I make my mark, okay? Pre-lab. Pre-lab's worth 5 points, okay? Then you've got the post-lab. The post-lab is 1 point per question. It's like this one, there's 8 questions on the post-lab. So the post-lab, the question part will be worth 8 points, right? And then the data is worth whatever's left. It's like in this one, the data would be worth 13, 12, 13, I don't know, something like that, right? And that'll be what the data's worth, and I'll go through. This will be the only thing you physically hand in all year of your labs. You'll bring them in, and I will go through them, and I will score them. Then I'll put them in the computer, okay? Every lab's worth 25 points. Clearly, he only got 20. I think that was because it was like 3 weeks late or something, okay? The only reason I accepted that is because he was a senior. And this was like our last lab we did. So, okay. So yeah, pre-lab, data, post-lab. Like I said, you will need these rulers. If you don't want to cut yours out of your book or whatever, come and grab one of these and you can cut that out. What I would do is I would only cut out the rulers. Okay, cut out the rulers. You don't need to cut these out because you can just lay it on there and see what the lengths are. You know what I'm saying? But you'll need to cut the rulers out. That's why I made that copy, so you can cut them out. Okay? You'll take the test in class. You will have time afterwards. That's when we start doing the Learn Smarts for the next chapter. We'll discuss that at length at that point. Okay? Right now, all that matters is that you do the lab at home this weekend because it will be due on Monday. When you walk in on Monday, and then all the homework will be due at 11:59 Sunday night. Do you all understand that? Most of you have most of it done, so it's not a big deal, but I just want to make sure we're all on the same page. And the lab should only take you, less than an hour. Okay, do it at home, read through it. The pre-lab, that's something you need to understand. The pre-lab is what tells you how to do it, and what they're doing is they're getting you to answer these questions to hopefully help force you to do the pre-lab. Down the road, if you don't, you can't do, because the labs you do are very involved, If you haven't done the pre-lab, you have no idea what you're doing. And if you have to try to read it and do it, you'll never get done, ever. Yes?
So we should put out the pre-lab, on, like, some, like, the book is like the online one? Is that what we did?
Yeah, everything is in there. So I don't, like I said, I don't, oh, wait, I do have one. This person hasn't picked this up yet. But look, right here. Here's an example of what it's going to look like. So every lab is the same. Okay? It's like for lab 1, it is going to start. I about tried to lick my finger. So what will happen is this. So here's a lab, right? Experiment 1. What they do is they give you some reading, and what they're doing is they're explaining you how to do it. So once I've read 1, 2, 3, 4 pages, right, that is going to allow me to answer the pre-lab questions. So I'm going to go through, I'm going to answer these questions. So there's only 8 there, and they're easy. So those 8 would be due when you walked in that door, right? So they'd have been done. And then during the lab, you're going to fill out these tables. That's what these tables are for. You're going to fill them out, okay? When you're done with that, then you'll go through and answer these questions based upon what you did in the lab. Does that make sense? And every lab is the same. It doesn't change, okay? So what you would need to print off is just the stuff you have to hand in. So what I had kids just print this stuff off. Just these pages. That'd be 1, 2, 3, 4 pages for this lab if you go front to back. Does that make sense? And that's all you have to hand in. Then they just brought their, and then you can just read it out of your book or off your Chromebook or whatever you use to do this other stuff. Now I had a student say she bought it on a Kindle and she was having trouble. If you buy the Kindle version, screenshot it, email it to yourself, print. Does that make sense? Okay. That's the way I found to get it to work. So whatever. Alrighty. That's that. Housekeeping. Any other questions? I think that's good. Does anybody have a picture of a question we need to look at from the homework? Anybody done the homework? About half of you. Okay, you're all done?
Yeah.
Oh, good, good, good. So, anybody got any questions they want to look at? Bella?
I don't have like a specific question, but could we go over like
Metric to standard? Yeah. What do you want to...
just like the whole like the fractions and different.
So like a conversion type stuff. Yeah. Yeah, we can do that. So let's say, so a common one would be like, let's say I want to go from, let's say I go 2.76 feet, right? And I want to put that in, let's say I wanted to go to millimeters, okay? So I'm going to go 2.76 feet, right? Well, where am I going to go first?
Inches.
Inches, right? So I'm going to times that by what? What's my first, what are these called again? They're called, starts with a C. Conversion factors, right? And I get a conversion factor from an, well, yeah, but what's it called? Conversion factors are simply a what written as a fraction. Starts with an E. I heard it. They're an equality written as a fraction, right? So, what's that going to be? 12 inches in 1 foot, right? Now, will that 12 and that 1 count as sig figs?
No.
No, because that's a given conversion. What's next?
The inches to centimeters.
Inches to centimeters, and what's that? And that's something I'd write down or no. You know what I'm saying? And it's what? 2.54 centimeters in 1 inch, right?
Yeah.
Then I've got to go from centimeters to millimeters. That is 10 millimeters in 1 centimeter, right? Centimeters reduce out, inches reduce out, feet reduce out. I do my math because I brought a calculator because Mr. Denton suggested that on more than one occasion.
Yeah.
And if I haven't, you need to bring a calculator every day. You cannot use a phone as a calculator on the test. So don't bring them. Don't try to use them anymore. Bring a calculator, okay? What do I got here? Anybody got this yet? Give me what your calculator spits out.
841.248.
841.248, and that would be millimeters, right? Now, how many sig figs can my answer have in it? 3, right? So I would be able to write, because of this, I could write 841 millimeters, right?
Yeah.
Or what else could I have written there and still been correct? Say that again.
8.41 times 10 to the 5th.
Second millimeters, like that. So either one of them, and just the only reason I do that is because sometimes they write answers in standard form, sometimes they write them in scientific notation. There's no rhyme or reason as to which ones they do that way, so just kind of be alert to that. Okay. If you get an answer and it's not there, the first thing I would think is, oh, it's probably scientific notation. If it's not there, then it's got to be, oh, I probably made a mistake. Because there's 32 questions, 31 are multiple choice. There's one written. They're brand new this year. They're like short essays, like really short. Again, watch the video I put on my Facebook, or on, not my Facebook, on my Canvas page. Sorry. Yeah, we are not friends. Okay. Although I swear this summer I got like Facebook requests from half the senior class from last year. It's like, oh, now. And I'm like, oh, yeah. You guys used to think that was the old people's tool. Okay. Does that make sense, Bill? Okay. Anybody else? Raise of hands. How many of you still do not have power? Oh, boy. Yeah. When did yours go out?
Tuesday at like 6:30.
Yeah, Tuesday morning at 8:30, my power went out. So, yeah, it kind of sucks. But hopefully today. Right, Bella? Bella and I are neighbors.
I hope so. They have to fix the tree before.
I know. Well, I'm not sure fix is the answer. They might fix it. They might fix it right at the bottom.
Yeah.
And it might be more than one. That's my fear.
Yeah.
Yeah, so. Bella's neighbors lost 2 60-foot pine trees, man. It was ugly. Power lines right on the grass. So. Well, alrighty. That's all I've got. Yeah, you need to do well. So study it up, okay? Get your Chromebooks out and get busy. Should give you time to get some stuff done. Even with the technical difficulties. Okay?